Good afternoon to all. Good afternoon to all. Welcome to TREIS online webinar classes. Myself, K.Swapna. PGT Physical Science from TSRS and JC Enkoor. Today we discuss about 9th class, second chapter, motion. Children, already you have learned this chapter in 7th standard. There you have learned about motion and rest, types of motion, and uniform and non-uniform motion. Now here we discuss this chapter in detail. In this chapter, we will discuss about the what is motion and rest, distance and displacement, speed and velocity, average speed and average velocity, instantaneous speed. Next one, uniform motion and non-uniform motion. Next one, acceleration. Next, equations of uniform accelerated motion. These 8 topics we will learn in this chapter in detail. What is motion? Familiar with the idea of motion. We see several examples of motion around us, like the motion of people, motion of vehicles, raindrops, flying birds, and the object thrown into air. These all are having motion. What is relative? Children, see, observe this picture. Right and left. Here see, the here two persons are there. One person is A, another person is B. The and beside the road, there one house is present. Which side of the road is the house? For this question, there are two answers. One answer is in point of view of A person, the house is present right side of the road. And in point of view of B person, the house is present left side of the on the road. That means the position of the house is relative to the observers. The right and left are relative to the observer. In the same way, up and down orientations like up and down be the same for all persons at all places? No. They change it with the point of observation on the globe. In the same way, motion is also relative to the observer. Children, observe these pictures. Observe these pictures. If people students are open sir. సార్ ఇప్పుడు నేను మ్యూట్లోనే ఉన్నారా సార్? అన్మ్యూట్లో ఉన్నానా? హలో సార్. ఓకే సార్. Children, see these pictures. Here two persons are standing on the road. One tree is present and one vehicle is moving towards the east. In point of view of these two persons, Somesh and Srinu, the tree has at rest, but the car is moving towards the east. That means in point of view of Somesh and Srinu, the car is moving and the driver and passenger in the car also has a motion. But in point of view of passengers and driver, the tree has in motion towards the west side, and the two persons also has in motion towards the west. in point of view of passenger and driver. And see here, the point of view of driver, in the point of view of driver, the passenger has at rest position. That means the motion and rest are the relative to the observer. Relative to the observer. Next, what is the definition of the motion? Motion. Motion. Motion means a body is said to be in motion when its position is changing continuously with the time and relative to an observer. Motion means not only movement of the body we call motion. That is depending upon the observer. Okay, now children, the position of the body is changing continuously changing with respect to time and relative to an observer. That we call motion. And what is the meaning of definition of rest? If the position of the body does not changes with respect to time and surroundings, then the body is said to be at rest. That means the object position doesn't change with respect to time and observer. That we call rest. Next topic is physical quantity. What is the physical quantity? I hope you children, you have an idea about you got an idea about the motion and rest. Next topic is physical quantity. Physical quantity means a measurable quantity is known as physical quantity. For example, mass, weight, distance, displacement, speed, temperature, etc. are called physical quantities. The physical quantities means measurable quantity. A measurable quantity is known as physical quantity. Mass is measured in grams and kilograms. Weight is measured in gram weights and kilogram weights. And distance is measured in centimeters and meters using the tape scale with different types of methods. And displacement also measured in centimeters and meters. Speed is measured in centimeter per second and meter per second using the speedometer. Temperature is measured in degree centigrade, degree Fahrenheit. And temperature we are using thermometer to measure the temperature. The physical quantities are mainly divided into the two types. Physical quantities are mainly divided into the two types. One is the vectors, another one is the scalars. Vectors means it is a physical quantity which has both magnitude and direction, is known as vectors. Vectors means the physical quantity. It is a physical quantity and that has both magnitude and direction. For example, displacement, velocity and force are the these physical quantities, etc. are the physical quantities. These have both magnitude and direction. Magnitude means what? Magnitude means nothing but value. It has some value and direction. For example, force is a vector quantity. The force, when we are applying some force on the object, when we are applying, suppose one object present, suppose on the table one book is present. One object is present on the table. When we are applying some force on it, some force, suppose 2 newtons of force is applying on this object. That time the object is moving which direction? From, we are applying the force from left to right. In the same direction, the book or the object is moving. That means it has some magnitude. Magnitude means value. This 2 is the value. Okay, na magnitude. And it has some direction. So the force is a vector quantity. Next one is the scalar quantity. Scalar quantity means the physical quantity which has only magnitude but no direction is called as scalar quantity. That here, see, the vector quantity means it has both magnitude and direction. But the scalar quantity means it has only magnitude, no direction. For example, time. When we express the time, 2 seconds, 3 seconds, 2 minutes, 3 minutes, up to 1 hour, 2 hours, like that. But we don't mention any direction of the time. So the time is a scalar. And temperature. Temperature is also scalar quantity. It has only magnitude, no direction. Mass also, it has only magnitude. There is no direction. And the vector quantities we are represented as a directed line segment. The vector quantity is always represented a line segment. The length of this arrow, then length of this line segment is indicate magnitude, and the arrow indicates its direction, and the point A, the line segment, the point A is called tail, and the arrow point B is called head. Okay, now? Next topic is distance. Next topic is distance. Distance is also known as path length. Distance is also known as path length. Distance, what is the definition of distance? The length of actual path covered by the body is called as distance. The length of actual path covered by the body is called as distance. Children, see this picture. Here, one boy has at A point. He is moving to B point. Then after he was moved at C point. The length of distance means the length of actual path covered by the body. The total length of the path of the boy we call distance. Okay, now that means the distance is here the total path A to B there is 3 meters and B to C 4 meters. The distance covered by the boy is 3 plus 4, 7 meters. The distance is a scalar. What is the scalar? Scalar quantity means it has only magnitude but no direction. See here. See here. The boy has direction. At first, he moved towards the east side, then after north side. So it doesn't have particular direction, no direction. It has only magnitude. That magnitude is 7 meters. Distance never be negative. The distance is never be negative. It is always positive. SI units of distance is meter. Meter. We indicated the small letter m. The CGS units of distance is centimeter. Cm, small c, small m, centimeters. 1 meter is always equal to 100 centimeters. See here the calculation, the total distance covered by the boy is AB plus BC. AB, the length of the AB is 3 meters and BC, the length of the BC is 4 meters is equal 7 meters. 7 meters. Next one is the displacement. Displacement means the shortest distance between initial and final point is called as displacement. The shortest distance between the initial and final point is called as displacement. See here, the boy is moving from A to B, then after move to B to C. What is the displacement of the boy? The AC will give the displacement of the boy. Displacement means what? The shortest distance. The shortest distance between initial and final point. Here see, the initial point is A and the final point is C. This shortest path of the boy is known as displacement. The shortest path of the boy is known as displacement. Don't confuse children. Distance means the total length covered by the boy. The actual length, actual path covered by the body is called as distance. And the displacement means the shortest distance between initial and final point is called as displacement. Distance means A to B, AB plus BC. This total length we call distance. But displacement of the boy means the point, the initial point to final point. This we call displacement. The shortest length of the initial and final point is known as displacement. Same like distance, displacement, SI units of displacement is meter. And CGS units of displacement is centimeter. And the displacement is a vector. It has direction. Vector means, vector quantities means the quantities, the physical quantities which has both magnitude and direction is known as vectors. So the displacement contains the magnitude and direction. See here, the boy, it has A to C. The shortest distance, the shortest distance covered by the boy is the initial and final point of the boy is called displacement. That means it has some magnitude and direction. Direction means it is the northeast direction and it has some magnitude. Okay, now? And so that's why displacement is a scale vector quantity. Displacement is a vector quantity. And displacement is maybe 0 or negative or positive. Displacement is either 0 or negative or positive. Okay, now children? All of you understand this difference between the distance and displacement? Distance means the length of actual path covered by the body is called as distance, and displacement means the shortest distance between initial and final point is called as displacement. And distance, the SI units of distance is meter, and the SI units of displacement is also meter, and the CDS units of distance is centimeter, and the CDS units of displacement is centimeters, and the distance is scalar quantity, that is, it has magnitude but no direction, and the displacement is a vector quantity. It has both magnitude and direction, both magnitude and direction, and the distance never be negative. That means it always positive. It will always positive, and the displacement is maybe 0 or negative or positive. See this. Okay, find out the displacement. Find out the displacement of the boy. See this picture. The boy, displacement of the boy. That means the length of the initial and final point A to C. This length we call displacement of the boy. How can we calculate the displacement? Procedure to find the displacement. First of all, note initial and final point. Then after, join initial and final point with a line, straight line. This straight line length give displacement. Okay, now? So here see children, first find the initial and final point. The initial point is A and final point is C. Then after, you can join the initial and final point. You can join initial and final point. This length, the initial and final point, the length of the initial and final point, this total length gives to us displacement. Say here, this is the right angle triangular. Okay, now this hypotenuse square is equal to the side square, the sum of the side squares. AC square is equal to AB square plus BC square plus BC square. AC square is equal to AB square. AB length how much? 3. This is a 3 square, not 3. 3 square plus BC. BC, the length of the BC is 4. 4 square. AC square is equal to 3 square. This is 3 square means 3 into 3. 3 3 is 9. plus 4 square. 4 square means 4 into 4. 4 4 ja 16. AC square is equal to 9 plus 16, 25. AC, we wanted to length of the hypotenuse. AC length. This is represents the displacement. AC is equal to under root of square root of 25. The AC is equal to 5 meters. The displacement of a body is 5 meters. And the formula of the displacement. Displacement is equal to change in position. Displacement is equal to change in position. That is final position minus initial position give to us displacement. The relation between the displacement and distance. What is the relationship between the distance and displacement? Displacement is always less than or equal to distance. Displacement is always less than or equal to distance. That means the distance is always, the distance magnitude is always greater. The distance value is always greater than or equal to displacement. If displacement is zero, corresponding distance may or may not equal to 0. May or may not equal to 0. Okay, now children. Today, work. Answer these following questions in your notebooks. Define the terms motion and rest. What is the motion and what is the rest? Next, second question. What is meant by physical quantity? And give examples. Distinguish between vectors and scalars. Third question is distinguish between vectors and scalars. Write the difference between the vectors and scalars. Third question. Okay, children. We will continue next topic tomorrow session. Thank you for all. Thank you to all for giving this opportunity. I am going to sign off.